Action.
All right, students, we got a little collab sesh going on today.
Oh,
Mr. Huang here, and we also got Mr. Thomas. Hey, hey.
Mr. T in the house.
And
We're so cringe right now.
it'd be kind of fun to do the notes together. So we're just going to get it started, and I'm going to have Mr. Thomas read our situation here, and then we'll get started with number one.
I don't want to read. I'm just going to turn my camera off.
Come on, Mr. Thomas, let's do it. Here we go.
Okay. A bakery uses the equation F equals 1.5 H to decide how many tablespoons of honey, H, to add to F cups of flour for bread. Do you want me to read the next part where it says 1?
Now let's stop there for now.
Okay.
All right, so we have two quantities here. We have H, which is honey, and we have F, which is the cups of flour for bread. And I think a good place to start, is to write up a table so we can understand, the relationship between the two.
Okay.
So I'm going to start by writing H over here and F over here as my second quantity and draw this table out. So what do you think we should put for this first row in our table, Mr. Thomas?
I think it makes sense to start with one of something. Let's see here. I don't know if we want one H or one F. I think it's usually easiest if we have a one in the left column. I like to think of those as X values, even though it's H here. Okay. And then based on the equation, it says F equals 1.5 times H. So I think I'm supposed to take 1.5 and multiply it by H there to get my F value. So 1 times 1.5 would be 1.5.
Right. And if any of you are wondering how did I decide what to put on the left and the right, I really did look at what Mr. Thomas was saying, which is the equation. H is being multiplied by 1.5, and I know that in our constant of proportionality or in the things we've been talking about, whatever's on the left column or the first quantity, we're multiplying by a number to get the second quantity. So that relationship is how I chose H on the left and F on the right. Okay, so that's a good start. I think in number two, we'll probably fill out more of the table, but why don't we do number one for now, which says, what does 1.5 mean in this situation? We know it's the constant of proportionality. It's the number we use to multiply from H to F. But contextually, Mr. Thomas, in this situation, what exactly does it mean?
Okay. Let's write K equals 1.5 like somewhere on there just to have that on the paper.
Let's do it. K
That's
equals.
exactly where I would have wrote it too. All right, so yeah, our K is 1.5, and what it means for us is that, I gotta be careful not to say this the wrong way. For every 1 tablespoon of honey,
For every one, maybe should have written the number, tablespoon of honey,
you need 1.5 cups of flour.
awesome. And hopefully you're noticing that that's exactly what we did here. This is a visual representation in a table form of exactly what Mr. Thomas just said here, which is that we have 1 tablespoon of honey and we have 1.5 cups of flour. And we can think about that as the constant of proportionality, but what else, Mr. Thomas, what else are we thinking about when we think about this? Any other thoughts before we move on to number two?
Well, just because we're talking about for every one of something, that makes me think of unit rate, right? If you know how much of one quantity you need for every one of another quantity, then that's the unit rate. That's the rate of for every 1 unit.
Exactly. Awesome. So number two is talking about filling in the missing information for each bread recipe. It doesn't look like anything's missing from the first one, so why don't I go ahead and just write that into our table over here. We have 14 tablespoons of honey and 21 tablespoons of cups of flour. And let's just make sure that the book knows what it's talking about. 1.4 times, or 114, sorry, 14 times 1.5 is equal to 21. So we know that our constant of proportionality remains the same. You want to talk about the middle one right here, Mr. Thomas?
Okay, so we have 5 tablespoons of honey, with honey being like our H value or X value in the left-hand side of the column, the left column of our table. And so I know that if I need that other value, which would be in the F column, I just want to multiply by my constant of proportionality, which is 1.5. So I need to know what 5 times 1.5 is.
And some of you guys do this with mental math. You take half of 5, and then you add that to 5. And I know some of you guys have been doing that, which would give you 2.5 plus 5, which is 7.5. But let's also just double check our answer, and we do get 7.5 cups using our nifty little table. And I'm just going to show the multiplying. We can never have enough connections in math, and so I'm going to also show the multiplying here as well. All right, Thomas, so we got one more here, and this time it's a little different because they're giving us the flour, but we need to find out the number of tablespoons for the honey.
Okay, so I know I shouldn't multiply because that wouldn't make any sense to me. If I know that I'm supposed to always have more flour than honey based on the numbers I'm seeing in front of me, then I don't want to multiply. So I feel like I should divide because that would work the relationship in the other direction. If I multiply my honey to get flour, then I should divide the flour to determine the amount of honey.
Right.
So,
go ahead.
18 divided by 1.5, I think is going to get me the answer I want.
Right. We've talked about this in our class for Mr. Wong students, where when you're going from one to the other and you're multiplying by 1.5 to go back to the original, or to go back in almost like a reverse kind of order, we're going dividing by to get from to have that relationship. So let's take a look. We have 18 divided by 1.5, and we get 12. And so that's our H value, which is our tablespoons of honey. Nice work, Mr. Thomas. We got one more left, and then the summary.
A truck is traveling at a constant speed. Its distance d in miles after t hours. What does that mean? T hours. How would you explain that to your students, Mr. Wong, if they're confused by what it means by t hours?
That's a great question. I would just say t is a variable, which a variable just represents a number. In this case, they're calling it t because we don't know what that number is, but it could be after 3 hours, after 5 hours, after 10 hours. It's representing a relationship between the distance and hours.
Okay, so after t hours, the distance is represented by the equation d equals 45 times t. Now, normally I would just say 45t, but I want to make it super clear for some of my students that might not know, when you see a number like 45 right next to a variable like t, that means to multiply them. So that says d equals 45 times t. And so it's our job to figure out how long does it take the truck to travel 18 miles. All right, so I want to use the equation I'm given, and I'm being given a value to put into my equation to make a substitution, 18 miles. Well, I have 2 variables in my equation. One of them is d for distance, and the other one is t for time. And the value I'm being given is 18 miles, which is a measure of distance. So I need to put that 18 where the d is in the equation. So I think I want to rewrite the equation as 18 equals 45t. So that's what I'm trying to solve. I'm trying to solve what is t in this case, or what do I multiply 45 by in order to get 18? And I know that's going to be a really small number. That's going to be some kind of fraction or decimal. Mr. Wong, I think you were saying we could try to figure this out using a table?
Yeah, so this might be confused. Some of you might know how to solve this, some of you might not. I want us to use a table to see how we can solve this. And we're going to do it very similarly to what we did earlier. So earlier you noticed we have h and f, and the number that is next, or the variable next to our constant of proportionality is our x, or our left column. And so I'm going to make that same relationship there. And I'm actually going to do it down here so we have a similar in the My Notes section. T is going to be on the left, and D is going to be on the right. And so, like Mr. Thomas said, we do want to start with the number 1. That gives us a very good understanding, because we know that whatever is multiplied, whatever we have for T is multiplied by 45. Just like earlier, whatever we had for H was multiplied by 1.5. Notice the similarity in these equations. They look very similar. So we're going to take this 45 and we're going to multiply by 45 to get our distance. And that lines up with the situation.
So that, oh, sorry, I didn't mean to interrupt, Mr. Wong, but I'm thinking, so that tells us that after 1 hour, we can go 45 miles.
Exactly, 45 miles per hour, which is our unit rate as well.
Okay, that's exactly what I was going to say. Thank you for saying it.
So what do you think we should go from here, Mr. Thomas? How do we use the table to figure out how long it takes to travel 18 miles?
Well, the value we care about is when the distance equals 18. That's what the question's asking us about. So I guess my next move would be to put an 18 in that right column, in the distance column. And so I know that this relationship's going to stay proportional. I have my constant of proportionality, the 45 that you multiplied by right there in the center of the 2 columns. And so we've done questions like this before. We know that if you multiply from one quantity to the other using your constant of proportionality, then in order to go the other direction, in order to take a value for D and get a value for T, we need to divide by that constant of proportionality. So I think we want to do 18 divided by 45.
Couldn't have said it better myself. 18 divided by 45, and we get 0.4, which is...
That's a weird answer. 0.4 of an hour.
That is kind of strange. Well, how many, I mean, we could talk about it real quick. How many minutes are in an hour? We got 60 minutes, right?
All right, 60 minutes in an hour, and we have 0.4 of an hour.
So if we know that of means multiply, then if I have, if I have 0.4 of an hour, that's 0.4 of 60 minutes. So I'm just going to do this on the side. This is a little bonus sneak peek for you guys of something we're going to do later in the year. If I do that real quick and do 0.4 times the number of minutes in an hour, I'll get 24. And so it's actually equal to 24 minutes.
All right. Do you feel like we need to write any sort of summary, Mr. Wong, or do you feel like I don't know, what do you think?
I feel like we did pretty good. I do want to write a sentence to answer the question.
Oh, yeah, that's good. That would be thorough for sure.
Yeah, so let's answer this and say it would take 0.4 hours.
That's not how humans talk, though.
Exactly. That's why I'm writing 24 minutes. That's true. Or 24 minutes for the truck to travel 18 miles. There we go. There we have it. Our answer to number 3.
All right. Well, I think we're all done. What do you think, Mr. Wong?
Yeah, I think I'm going to write one short sentence, and all I'm going to say is that the constant...
Mr. Wong is so thorough.
Proportionality. Gotta give him that extra, that extra sauce, Constant proportionality is similar to, you might even argue exactly the same, but we don't want to get into the nuances of that, but it's similar to units rates. Hopefully you've seen that it is related to each other, that there's this idea, there's a relationship between a constant of proportionality and a unit rate.
Mr. Thomas actually would argue that they are exactly the same. But my street cred is really low right now because I said constant is the same as scale factor, and that wasn't right. So All right. Anything else, Mr. Wong?
That's it. Sounds good on my end.
All right. So then I think our students should probably be going to do some IXL practice now.
Sounds good. Yeah, sounds about right. And I will catch you guys later.
All right. Go do your IXL. See ya.